The volume of a right circular cylinder is pi r squared times h. If our diameter is 3, that means our radius is 1.5. The height is about 6 inches. What's the largest number of full milk glasses that you can pour from 1 gallon of milk? And they tell us how many cubic inches there are. So volume is equal to pi times 1.5 squared times 6. If you multiply that out, you get somewhere around 42, just over. If you divide 231 by 42, you get 5 point something. And they want to know the largest number of full milk glasses, so the answer is 5. We have two rectangular prisms that are similar. The longest side corresponds to the longest side. So the formula is length times width times height. And we know that there is a scale factor between the two. If you take 96 divided by 12, you'll find that this top one, the volume is 8 times as big. What you'll find, though, is that each part is twice as big. So 2L times 2W times 2H. And that's how you get 8 LWH compared to the original LWH. So if this big one was 6, the small one is half of that, or in other words, 3. For this right triangular prism, the volume is the area of the base times the height. In this case, they give us the volume, and they just want to know what is the area of the triangular base. So we take the volume, and we divide that by 12, and we get 8, which is the area of the base. Right circular cylinders have a volume of pi r squared times the height, and they're telling us that the height is 1 meter and the radius is 0.05. So we can take 0.05 squared times 1 times pi times 94, because there's 94 of these sections. And even after you multiply all of those things, you get 0.738, which is the closest to D. Cylindrical can, so that's going to be pi r squared times height for the volume. The base has an area of 75, and the height is 10. So 75 times 10, the volume is going to be 750. We have 110 of syrup, so that leaves 640 for fruit. They give you the formula for the volume of a sphere, and we're comparing two spheres, planet Jupiter and planet Earth. And planet Jupiter has a radius that is 11 times bigger. So when we plug that into the formula, that's going to come out as 11 cubed. 11 cubed is 1,331. So to find the volume of this entire grain silo, we'll break it up into pieces. The top one, we'll use this formula, the middle here, and the bottom, the same formula as the top. So this top formula, I'm going to take times 2, since it shows up in both places. And I end up with 250 over 3 pi plus 250 pi. So I could convert this to 750 pi over 3. And I end up with 1,000 pi over 3. When you multiply that out, you get 1047.2 or so, which is D. So the height has a range between 7.75 and 8, and the radius is 2. So I'm going to pick the whole number 8 and plug this in. And I get 32 pi, which is right around 100. In fact, it's 100.5. So if we round it to the nearest inch, I could say 101. Other answers that would be accepted, 97, 98, 99, or 100, if you went with one of those heights that was a little bit smaller. They tell me the volume is 72 pi, so I can write that 72 pi is equal to pi r squared times h. I'm going to get rid of the pi's by dividing from both sides. I'm going to plug in that h is 8, and I'll divide that out, so I have 9 is equal. And when I take the square root of both sides, that gives me 3 for the radius. But they want to know the diameter, so I'll double that, and the answer is 6. The volume of a sphere is 4/3 times pi times the radius cubed. So the volume of sphere A is 20 cubic centimeters. Sphere B has a radius that is 2 times as big. So if I think about 2 cubed, that's going to be 8. So I take this top one and multiply it by 8, and the answer is 160. So we know that the formula for density is equal to mass over volume. And to find the volume of slab 1, we're going to multiply the 3 dimensions, length, width, and thickness. So if we take 100 times 20 times 8, we get 16,000. That's the volume. And I'm going to plug in the mass from the table. So I have 44,000 divided by 16,000. So the density is equal to 2.75.